This video is to help you get started with tonight's homework on amplitude and period for sine and cosine functions. For problems 1 through 9, you can see that you are given sine functions and cosine functions. And the directions say to determine the amplitude and the period of each function. So I'll do a couple of them. For number 1, we've got y equals sine of 4x. If you recall, we've got y equals your amplitude times sine frequency x, or y equals a sine bx. That's to help you remember that your a is your amplitude and your b is your frequency value. You also need to remember that to find the period of a function, you have to take 2 pi and divide by the absolute value of your b value. So looking at this function, my amplitude is the number in front of sine. I have an understood 1, so my amplitude is 1. That means that my max is at 1 and my min is at -1. To find my amplitude, I need my b value. So I'm going to state here that my b is 4. So my period is the absolute, or is 2 pi divided by the absolute value of 4, which is 4. Which is, when we simplify, reduce 2 over 4 and we get pi over 2. So my amplitude is 1 and my period is pi over 2. I'll do it a little bit different. Let's do 9, since it's a little different and it's a cosine function. So recall that amplitude, again, is the absolute value of your a value. So even though we have -3 here as an a value, my amplitude is going to equal the absolute value of -3, which would be 3. Now, amplitude, remember, is kind of, if you can relate it to the volume, it means your max volume is at 3 and your min volume is at -3. To find the period, we need to identify our b value as -2, remembering that your period is 2 pi divided by the absolute value of that b value. So if it's negative, just use positive. So 2 pi divided by 2 would just give us a period of pi. All right, so you'll continue likewise to finish all the other ones, 2 through 8. Next, it says, I'll go ahead and do 10 for you. It says, give the amplitude and period for each function graph below. Then write an equation of each graph. So the first thing you want to do when you look at this is decide, are you going to write it as a sine function or is it a cosine function? So when you look at this one, you can see that it crosses here at the origin, then it goes up, then down, then stops right here. So in order to write the function, we need to first decide sine or cosine. When I look at this, because it starts at the origin, I would call this a sine function. So your job is really to write the equation as y equals a sine b of x. So you need to determine the a and the b value. Well, your a value, again, is your amplitude, so all you have to do is look at your max and min, and you can see it goes 3 to -3, so your amplitude is 3. Your frequency, however, is pi. So since you need the b value, but don't know it, you know that 2 pi divided by b should give you the period. Well, the period, if you look, the cycle begins at 0 pi and ends at pi. So we know that our period, when we divide by b, should end up equaling pi. So you can use logic to think through this, or you can multiply and solve. So we get 2 pi from our numerator, multiply pi times b. So that means that b is 2. So my function, y equals 3 sine 2x. I'll do one other to help you out, one that's a cosine function. So looking at 13, again, I would look at it and say, well, where does it hit along my y-axis? And you can see that it hits down here at -5. Since it is not at the origin, I can see that it stops here at 2 pi, but I would definitely recognize this as a cosine graph that happens to be reflected, because normally it would start at the top, go down, and then end here at the top for one cycle. So I know that this is reflected. So I know that my a value is going to have, my function is going to have a negative in front. I need to determine my a, my cosine, my b, and then have an x. Well, my amplitude is going to be determined by, again, the max or min. So because that's 5, I'm going to have 5. Remember that the negative has to do with the fact that it's reflected. The amplitude is 5. Remember, it's the absolute value here. So if my amplitude is 5, this here should be 5. Then I need to see what my b value is, but that's, again, determined by my period. So remember, your formula for period is 2 pi divided by b, but because our period equals 2 pi, our b value must equal 1. So that means I have an understood 1x, so I'm not going to leave it like that. Actually, I want you to write it as y equals negative 5 times the cosine of x, and that would be your function. So that's 2 of those. You should now be able to go ahead and write the equations for 11 and 12. Now I'm going to fast forward here to problem 14. If you want, you can write, if you read the directions, it says, give the amplitude and period of each function, then graph the function over the interval from negative 2 pi to 2 pi. And then graph them on the graphs provided, and be as accurate with your graph as possible, and make sure your zero crossing are correct. So remember, your zero are your zeros here are your x-intercepts. All right. So instead of writing the amplitude and period up here, if you look at your graphs, you've got the function written beside each one. Well, find the one here on the back. The functions are written here on the side, so you can put your amplitude and period here if you like. So when we look at this function, 3 times sine x, we know that a sine function should look like this, where it goes through the origin. But because we have this 3 in front, we know that our amplitude is 3. So that tells us we have a max at 3 and a min at negative 3. If there is not a number in front then of our x, then we should know that that's an understood 1. So that means my period is going to equal 2 pi. So when you graph this, understand that your graphs are in degrees, but that 360 degrees is 2 pi. And we are supposed to graph this on the interval from negative 2 pi to 2 pi inclusive. If we go in the negative direction, it only goes up to negative 270. For all your graphs, you're going to need to come over here and put negative 360, which is negative 2 pi. So you need to graph it from here to here on every single one. All right, so to get started, we know that the sine function begins here at the origin. And because our period is 2 pi, you know that it ends right here at 2 pi. So my recommendation, every time you graph these, graph the beginning point and the end point for one cycle. Now the sine function, remember, looks like this. So we have one there, we have one directly in between the beginning and the end, and there's the one at the end. So if this is my beginning and this is my end, I know that halfway between I should have another 0. I know that because my amplitude is 3, we've got this line up here. I'll just use this to gauge and do this as 1, 2, 3. Negative 1, negative 2, negative 3. I know that it should reach a max point halfway between my first two zeros. So halfway between 0 pi and pi, I'm going to have a max point. And halfway between pi and 2 pi, I'm going to have a min point. So we need 5 points to graph all of these functions. 5 for the sine function, 5 for the cosine function. We're going to repeat the function likewise on the left side, but it's just actually if I take it and I copy it, that's what it should look like. So again, just to repeat, halfway between, I should have my max. Halfway between these zeros, I should have my min. And then I sketch the graph. And that's that. Now if I want to go and graph a cosine function, let's see. Give me a second to find another, well, I can use this. Well, maybe not. I already wrote all over that one. Well, I don't really have any extras, so I'm just going to do a cosine one on the back. So I'm going to sketch the graph here for 17 to do a cosine one. So your function is y equals 5 cosine 2x. Again, first thing you need to do is identify your amplitude and your period. So amplitude is 5, so my max is 5 and my min negative 5. And my period is 2 pi over my b value. So that'll be over 2. But 2 pi over 2 reduces to pi. So I'm going to put negative 2 pi over here, positive 2 pi here. Because my amplitude is 5, I'm going to make 5 tick marks and put a point, or I shouldn't put it, well, it's not going to matter. 5 tick marks up here for 5. 1, 2, 3, 4, 5. Down here is negative 5, and I'm going to graph it. Now what I want you to memorize is, and really know, is visually, you should know that that's what the one cycle of the cosine function looks like. So remember that you start and you end at the same exact point. Well, if my period is pi, then I'm going to start and end at these max points. So these max points are going to be at 5. So I'm going to start at 5, and because my period is pi, I should end this cycle at pi. I know that these 2 points relate to these 2 points. You should know that halfway between these 2 points, the beginning and the end, is your minimum point. So halfway between my points here at 0, pi 5 and pi 5, I'm going to put right here at pi over 2, I'm going to put my minimum point. Now we should also include zeros on our graph. Like I said, you need 5 points. So I should understand that if this was my graph here, then it would cross halfway between, half the distance here. So if I think about this on my axis, then right there, halfway in between it, is going to be my 0. And I'm going to have a 0 there. So now I have my 5 points. I kind of want to make it curvy and do the best job I can, but that would be one cycle of this cosine function. And then because I need to extend it to 2 pi, I need to repeat. So this would be my starting point, my end point, my midpoint, zeros, and repeat. Do the same for the opposite side here. My max up here, min down here at negative 5, zeros halfway between, and then repeat the process at negative 2 pi, 5. And there is my cosine function graphed on the interval from negative 2 pi to positive 2 pi. Good luck with the rest of your graphs, and remember that you can always type them in your calculator to check. Just real quick, if I want to make sure my graph looks right, I can always set my max to 5 and min to negative 5, make my graph from negative 2 pi to positive 2 pi, and hopefully exactly what I see in my window. Oh, I didn't type my function, my bad. 5 cosine 2x. Hopefully, because I've set my window again from negative 5 to positive 5 on my y, negative 2 pi to 2 pi on my x with intervals of pi over 2, it looks exactly like what I see on paper. If you do that, it should work for the whole assignment. So I have down, up, so I've got 1, 2, 3, 4, 5 peaks, 1, 2, 3, 4, 5 peaks. So my graph does match. Good luck with your homework problems.